Hello everyone, this is Professor Reimer. This video is for my world history class on Thursday, February 25th and Friday, February 27th. It's entitled The Scientific Revolution, and in this lesson we will explain the major causes and effects of the scientific revolution by responding to a writing prompt. If you're following along on the note-taking guide that I included in the Google Classroom assignment, there's a place for you to write this objective and also a place to write the EQ or essential question, where you simply turn the objective into an essential question that you hope to answer by the end of the lecture. What were the major causes and effects of the scientific revolution? So before we jump into our preview, I thought it would be beneficial if I showed you the writing prompt. That way you're thinking about the writing prompt as we are going through these slides. So here it is. It's based on a quote from Sir Isaac Newton, one of the major scientists we'll study in this lesson. He once said, "If I have seen farther than others, it is because I have stood on the shoulders of giants." So who are some of the giants that he relied on, and how did they influence him? But also, who are some of the giants on whose shoulders you stand, and how have they influenced you? So it's a two-part question. The first part related to the history, the second part related to your own life. So I hope you have some fun with that. But before we get to the process and assignment, we need to explore some of these giants. And let me say that my talk today is related to, or relies on, I should say, this book called The Scientist by John Gribbin, who very beautifully, elegantly traces the evolution of Western science. And he shows that the scientists were not necessarily geniuses, not necessarily like sitting in the room and creating these new discoveries in isolation of one another. They certainly built upon each other, and it wasn't so much that one person was smarter or better than another. It was simply like all the pieces came together for him and others at that time. It's like when you're putting together a puzzle, and I don't know, we used to do these when I was a kid as a family. We'd all gather around and we'd work on sections of the puzzle, and then we'd walk away, and it would be left unfinished, and then someone would come along and work on a piece of a section of the puzzle and then get stuck, and then someone else would come along, work on that exact same section, but like could see the pieces how they would fit together. And it's kind of like that with these scientists. They are building on the works of others, all working on some of the same problems, and when the timing was right, boom, right, the discovery is made. So with that introduction, let's jump into the preview. What are the steps of the scientific method? Pause the video, write them down. You've studied them in science class. All right, here they are. This is one of the breakthrough ideas to develop during the scientific revolution. Make an observation of some natural event, form a hypothesis, which is a possible explanation, perform experiments to test that hypothesis, analyze and draw conclusions from the results. Do the results support the hypothesis? If no, then you go back to the earlier steps where you revise your hypothesis and perform more experiments until finally your results support the hypothesis. Then you publish for other scientists to review and be able to duplicate, right? This is like, we almost take it as a law, almost like truth, but in fact it is a method that is not that old, and it is a product of the scientific revolution, which we will turn to now. We're going to take it in 6 parts. Before, right, causes as in the objective, and then the effects, and we'll pay a large chunk of our time to some of these main scientists. Remember, you're working on these, the giants that Isaac Newton stood upon. All right, so in brief, what is the scientific revolution? It's the beginning of a great intellectual transformation that leads to the modern world, a shift in the way of thinking. And remember, we've talked about contextualization, right? This broader context, this broader world in which some historical event is happening. It's happening at the time of those religious wars after the Protestant Reformation. in the 16th century. It's happening around that time. And by the end of the scientific revolution, Europe is going to embark on the Enlightenment, a movement that we will explore in the next class, and is going to directly result in many of the political revolutions that are the subject of this unit. So remember, this is in the same time period as those revolutions, and it's like bridging from our previous time period where we talked about the Renaissance and the Reformation. So let's now turn to, how did people think before the scientific revolution, right? Just briefly, right? What is science for? It's the how things happen, and a lot of times people think there's this debate between religion and science, but I don't really see that they are at odds, because they seek the answers to two fundamentally different questions. So science seeks the how things happen. Religion is the why, right? Science can explain how the world was created, or at least science can create a theory for how the world was created, but they have no possible answer for the why. And religions can supply that answer. So pre-scientific revolution, right, quote unquote scientists, who actually were usually just priests or monks, right? Those were the educated people of the time. Their intent was to use science to, quote unquote, prove God exists, or in other words, to learn more about God, right? If God created everything, right, you, by exploring that everything, then you would not only prove that he exists, but you learn more about him. And science was known as natural philosophy, and people who engaged in these scientific pursuits were known as natural philosophers. But it was much different, right? It was not based on observations of the natural world. It was mostly reading and studying and regurgitating, repeating some of these ancient authorities, which we'll turn to next. The most important, chief ancient authority is Aristotle. I mean, his ideas dominated how the world was thought to work. I mean, for like a millennia, over a millennia, he was prolific in his study, in his writing of all kinds of natural phenomena, biology, chemistry, physics, and government, right? And his method of was based on a logical argument that relied on induction alongside deduction. So one example is here on the right hand side of what we mean by his logical argument. This is one of his syllogisms, right? So all men are mortal, all Greeks are men, therefore all Greeks are mortal. Okay, so you take some truths, and you can discover some other truths, right? And he did combine some induction as well. So like he went out and he collected data, but that he didn't conduct experiments, right? So he collected data because he wanted to see patterns, right? And like this syllogism suggests, and then from those patterns create explanations. Now we could spend an entire class just on Aristotle. I mean, his range was wide, but for our purposes of the scientific revolution, he had some key thoughts on physics and the laws of motion. He argued that the natural state of an object is at rest, right? And it only will move if some force is acting on it. And once that force stops acting on it, it'll stop. Okay. He also thought that the natural motion, as in not motion like we were just talking about, where like something is acting on something else, right, depended on the element. So in the heavens, right, the bodies move in circles around the sun, but here on Earth they move up and down based on their weight. In other words, if something weighs more than something else, they will fall at different rates. Now, if you're thinking to yourself, that's not what we learned in physics class. Yes, right? This is not a complete understanding of the laws of motion, but no one really challenged Aristotle for over 1,000 years until the scientific revolution, which we will get to. So if you're still wondering, like, all right, what's the difference between inductive and deductive reasoning? Here's a great chart. So remember, he relied on a combination, but for nearly everyone after and for most before, like, they were deductive reasoners, right? They went from the general, and I'm on the right-hand side, to the specific, right? So you make some general statement and then deduce or draw some conclusions. Then if the premises are true, then the conclusion must be true. So for example, all triangles have 3 sides. Shape X has 3 sides, therefore shape X must be a triangle. However, if your beginning premise is not true, or your logic is sort of flawed, you can reach some inaccurate conclusions. And I'm thinking now of this great scene from Monty Python and the Search for the Holy Grail, where they're conducting a witch trial, which we'll get to talk about witches here in just a minute, and they're trying to decide if this woman is a witch. And long story short, they eventually reach or they're deducing, right? Witches float. We could throw her in the water to see if she would float. No, that's too difficult. Ducks float, so if she weighs less than a duck, then or she weighs more than a duck, then she will not float and therefore is a witch. I go watch the clip if you really want to see it, but eventually they weigh her against the duck, and she obviously weighs more than a duck, and therefore they conclude that she's a witch. But the logic was flawed. With inductive reasoning, you go from the specific to the general. So reverse, right? You make specific observations, form a hypothesis, test that hypothesis, and if the test keeps supporting the hypothesis must be sound. And if you're like, wait a minute, that sounds like the scientific revolution from what we were just talking about, you were right. The scientific method is a form of inductive reasoning. For example, Medicine X has been tested on thousands of people and has been found to cure disease Y in every case. Therefore, Medicine X is a cure for disease Y, right? I'm thinking of the trials of the vaccine for COVID-19 that were conducted last year, right? It went through that scientific process to support that the vaccine, in fact, is not a cure, but a way to prevent COVID-19. All right. The other major ancient authority to note is a Greek writer, thinker named Ptolemy, who not created, but the system that is related to this is named after him, right? He, like many others, was building on all these other ideas, but it's known as the Ptolemaic system, or the geocentric system, which put the Earth at the center, and you can see it there in the diagram, and in 10 concentric rings was the universe, right? And each sphere was this like crystalline sphere, right, with the moon and then Mars and the various other planets. And these bodies were thought to be pure orbs of light that rotated in perfect circles, and you see the circles represented on the picture. In that 10th sphere is what moved everything, right? It moves itself and everything else, and beyond that was where heaven, right? So one end of the universe was heaven, where God lives, and at the other end is the earth, right? And that was how the universe was thought to sort of exist for much of world history before the scientific revolution. All right, I mentioned witchcraft. In the Middle Ages, right, the witches were thought to be a very present threat to the natural world, and many were convicted, and had to do these heavy penance, like punishments, um, because they were thought to be misguided. By the time of the Renaissance, people believed that witches flew, ate babies, and had committed this pact with the devil. My point in bringing this up is that there's this level of reliance on sort of unnatural explanations for natural phenomena. Like, why did my baby die? It must have been because a witch ate it, not because germs, caused my baby to get sick and to die. Because I don't know what germs are, but I think I know that there are witches out there, and that explains how my baby died. In other words, like an explanation for these natural events that's not based on inductive reasoning. So, to root out supposed witches, right? There are major witch hunts in the 16th and 17th century. You've probably studied the Crucible or the Salem witch trials. These witch hunts were often in areas experiencing religious conflict. So what we mean by that is it was a way to sort of demonize your religious enemy, right? They must be under the influence of witches. That's why they're proclaiming these like heretical, false beliefs. And just to give you some numbers, right? Between 1450 and 1660, 110,000 went on trial, 60,000 executed, and that's only for church or like government officiated trials. There are others, examples of communities acting out on their own. And what's most sad is that women were 75% of those executed. So these witch trials were also a way for men to retain their dominance over women, as well as a way to demonize and get rid of enemies, sadly. All right, but this is an example of this magical thought that it was magic that could explain natural events, and it was either like good magic, right, tied to the church, the work of the angels, or bad magic, usually the work of the devil or the work of demons. And so you would try and you would have these charms or you say these chants. You would go see like special diviners to try to like ward off this bad magic, because you didn't have any other way of explaining what is happening in the natural world. That begins to change in the Renaissance. So for a couple of reasons. So now we're moving into causes of the scientific revolution, right? We were laying the foundation there with the context and the way things were before, right? This intellectual transformation happens for a couple of reasons. Number one, Europeans, remember, are exploring the world. They're expanding their trade. And in doing so, they are encountering new problems like how to navigate across open sea, right? How to calculate how much weight ships could hold. Like, I want to bring back all this gold and silver from the New World. Will it sink my ship or not? So this leads to like the need for better math, better technology, right? You have universities improving their ability to read Greek, which means they can read other ancient writers, not just Aristotle. And they discovered that, wait, people back then disagreed with Aristotle. We thought Aristotle was like the prominent only thinker of the day. And remember in the Renaissance, especially when we looked at the painters, right? Mathematics was really valued as a way to uncover the secrets of the natural world. And there's this increasing humanism, or the putting of humans first, and improving humans mind and body through education, like history and rhetoric and language and sports. All these are contributing to this new way of thinking in the scientific revolution. I mentioned the Reformation. A key contribution of the Reformation is that it opens up the possibility that the religious authorities might be wrong, right? if you start to question which is the right church, now maybe you then begin to question what the church has been teaching, like about the nature of the universe. And the people who are questioning and examining the natural world can now spread this new knowledge much more quickly through the printing press, much the way that these new religious thinkers in the Reformation were spreading their own ideas. So let me pause there. Right, it was a little bit long for our first section, but take a deep breath, pause, go back over your notes before you check out this check for understanding. Pause, go back over your notes, and if you printed them, and I really hope that you did, right, you were filling them in as you went. On the left-hand side, there's a column there for questions. So put in the left-hand side some questions that can be answered on the right-hand side. Just who, what, where, when. For example, we just went back to this previous slide, like how did the Reformation lead to the scientific revolution? Or how did the Renaissance help lead to the scientific revolution, right? So pause, go back and do that, and then answer this question. All right. Did you get it right? It's C. Revolution was most influenced by ideas from the Renaissance. All right, let's move forward. Remember, we are explaining the major causes, which we just did, and the effects, which we're moving towards, of the scientific revolution by responding to a writing prompt, right? That quote from Isaac Newton about standing on the shoulders of giants. Let's now explore some of those giants. But before we do that, again, let's step back and look broadly at some principles of the revolution. And I made it easy with an acronym, query, right? Query is a question. And that is actually one of the major principles of the revolution, it's questioning, right? When you make an observation and it's different from what you expected to happen, right? You don't then resort to some magical explanation for what happened. You launch more investigations, more questions, more experiments to try to uncover more of the secrets of nature, right? And you're going to use mathematics to do that, right? This language, universal language of the natural world. That's the U in our acronym. The E, experiment, right? You make an observation, you have an hypothesis, and then you want to experiment. Like, is my hypothesis, is it correct? Right? You do that through experiment. The R, reason over faith, right? Religion is no longer the only possible explanation for events. It might be if through your questioning and experimentation, you can't quite explain things, but most of the time, right? Reason is going to be the way people shift to understanding the natural world, right? Using the human mind to explain natural events. And the last letter, the Y, yell, right? One of the major principles of the scientific revolution is to publish results so that others can review, duplicate, use to further the science. All right, so if that sounds a lot like the scientific method, yeah, right? That's the scientific method in an acronym. Use it if it helps in your science classes. All right, let's turn to some of those main scientists. And remember, you're going to explain how these scientists helped Isaac Newton see further than anyone had before him. So first one to talk about is Nicholas Copernicus, Polish priest, studied mathematics in Italy, returned to Poland, began working on astronomy, and he wrote a revolutionary, see what I did there, book called On the Revolutions of Heavenly Spheres. One of the first times this word revolution is used. And he argued that these revolutions of heavenly spheres went not around the earth, but around the sun. In other words, the sun, not the earth, was the center of the universe. In other words, it's a heliocentric universe, not a geocentric, as Ptolemy and so many who came before him had argued. However, he retained that circular planetary motion, right? It would be left to another individual, Johannes Kepler, again, student of mathematics, astronomer, who collected numerous data from observations of the heavens, of the skies, to determine that the planets actually move in ellipses, like a flattened curve. Think like the shape of an egg, but two-dimensional, right? With the sun as one focus. That's his first law of planetary motion. Second, that the velocity of a planet is not uniform, and that third, equal area of the plane is covered in equal time by the planet. So now we have heliocentric version or understanding of the universe with elliptical orbits. The next person to enhance humans' understanding of the universe would be Galileo Galilei. Again, an astronomer who uses a new technology, a telescope, to make some startling observations that there are mountains on the moon. There are sunspots, as in, spots on the sun. There are moons orbiting Jupiter. And so it like blows up the people's understanding that, wait a minute, the heavenly bodies, they're not pure orbs of light. They're made of like the same material substance that we have here on Earth. Like, what? That blows people's minds. In fact, so much so that he runs into some problems with the church. But we'll get to that in just a minute. He also made some key contributions to the laws of motion, right? Think back to Aristotle and his understanding of laws of motion. Galileo proposed that falling objects fall with uniform acceleration. And there's this famous tale that he went up to the Tower of Pisa and dropped like a feather and something heavy, I can't remember, to see if they would both land at the same time. Probably didn't happen. But he's one of the first ones to make this this proposal, which science has tested through experiment to prove correct, that falling objects do fall with uniform acceleration if it's in a vacuum. In other words, no other forces are acting on it. This is different than what Aristotle argued. He argued that it depended on the weight. Turns out, no, it doesn't. Also, he concluded that objects retain their velocity in absence of force. In other words, objects are naturally in motion instead of what Aristotle taught, at rest, and they will stay in motion until like some other force acts on them. In other words, this is this principle of inertia, which you studied in science class. So he argued for separation of science and theology because humans are endowed with reason. The church doesn't agree. Bans him, places on house arrest, and he has to recant his heliocentric system to save his neck. But that doesn't mean that it went away. Some others. Francis Bacon insisted on using inductive reasoning, right? We talked about that earlier. Make lots of observations about particular natural events, then generalize about rules of nature. Don't start big and go small, right? You start small and go big. He was really a key proponent of this modern idea of progress. We talked about this back when we talked about the Renaissance, that you can improve the human condition, you can improve the human mind, you can improve the human world, right, by the application of this science. In other words, human power can be used to conquer nature in action. We could apply this science, which was a key difference really between the English and the French schools of thought. French were mean it more for like pure science, just for like understanding and knowing new parts about the natural world. Bacon and many other English scientists were really wanting to apply that science to improve human power. And we'll get to that when we start talking about the industrialization. All right. If you like, what was inductive reasoning? Going from specific to the general, deductive reasoning from the general to the specific. All right. Another key scientist, and he wasn't really even a scientist, is Rene Descartes. He was a philosopher who brought this philosophical perspective to the natural science. He said, wait, let's step back. How do we know what we know? I don't know. Let's start with doubt. I don't know anything. Wait a minute. I know one thing that's beyond doubt, like in my own mind. He said famously, I think, therefore I am. So the mind cannot be doubted, but everything else can, like the body, the material world, like all that can be doubted. I know I exist, so that's not in doubt. So it leads to this separation of mind and matter, which means that you could investigate matter with the mind using reason. And this is what we do in the scientific method. All right, are we to? Yes, here we are. Sir Isaac Newton, right? And John Gribbin argues that perhaps one can make the case that a true genius would have been Isaac Newton, probably the greatest scientist possibly who ever lived. He's born on the day that Galileo died. His chief achievement is simply known as the Principia, after the Latin part of the title. So he brings everything together. Would someone else have done the same thing? Gribbin argues, yes, right? But it's Isaac Newton who gets credit for it. He published it first. And to bring everything together, he had to create a new science, calculus, which, thank you, Sir Isaac Newton, for my struggles senior year in calculus. I did not enjoy it. So thank you, Sir Isaac Newton. In the Principia, he argued that there is one universal law to explain all of the motion, both on Earth and in the heavens, and that is gravity. That every object in the universe is attracted to every other object by a force called gravity. That is how we can explain the motions of the heavens and on Earth. So what comes out of this Principia is this radically new picture of the universe. Not one in which angels and demons and witches are at work, but one in which functions according to natural laws. And he put forward 3 laws of motion. And there they are. Bodies move in straight lines. Galileo thought they moved in curved lines. He said straight lines unless impeded upon. So this idea of inertia. Every action has an equal and opposite action, and every body attracts every other body with a force proportional to the distance between. So this is this new understanding of the natural world until the 20th century. But then Einstein comes along with his theory of relativity and blows up this understanding again. So this is not like the finale of the scientific revolution. This is not the end. This is just a key marker in this journey toward a greater understanding of the universe. All right, now let's end with the effects. Socially, the rich get richer, mostly because these new technologies, this new understanding are going to widen this intellectual gap, and the rich are going to capitalize on these inventions. And we'll see that a lot more when we get to the Industrial Revolution. Obviously, it accelerates scientific and technological discoveries and innovations. Navigation improves, map making improves, artillery, right? Shooting shells and calculating how, at what force and at what angle, right? That's going to get better. We're going to get better at providing medicine as scientists open up the human body and dissect it and discover that actually the heart is the center of blood pumping, and that the blood is in a system that goes out and back into the heart. And the scientific method is going to become the standard for research. It still is that today. And so when we listen to our leaders and our public health experts, when we're thinking about the pandemic, right? The results that they came to, did they use scientific methods to reach their conclusions, or did they use some flawed logic to deduce something that may or may not be true? Like, we are still having this debate about how we know what we know, even to this day. But thanks to the scientific revolution, right, natural law becomes fundamental to the order of the universe. In other words, the universe operates according to laws that can be discovered by man. It does not operate according to unknown forces like God or the devil. And lastly, right, we now accept the heliocentric theory of the universe, reject some of these more obscure medieval scientific notions. And the West, it was moving toward a secular worldview in the Renaissance, and the scientific revolution is going to speed that up. And Gribbin would argue sort of science has replaced the role of religion in Western thought. So that's for another time. I'm out of time here. Went way much, probably too long. Hopefully, excuse me. Hopefully not too much. You made it. Think of it like 2 videos back to back. All right. Let's end with a check for understanding. Pause, answer, check back, see if you got it right. All right. Did you put A? Yeah, that's the right answer. Law of gravity revolutionized, completely changed 18th century physics. All right. Let's end with this processing activity. This is what I want you to write and put into Google Classroom for a grade. Both who are some of the giants Isaac Newton relied on and how did they influence him? I'm looking for like maybe a paragraph to 2 paragraphs, maybe 1 paragraph. You tell me about the history, and then in the second paragraph, I'm gonna do a personal reflection, right? Who are some of the giants that you stand on? Maybe it's your father, maybe your mother, maybe there's an uncle, a grandparent, older sibling, right? How have they influenced you? Can't wait to read your responses. Thanks for watching. See you next time.